Alright, so this is part 4 of the collections series, where we talk about the various different types of collections and Java's built-in structures. So, the utilities provides many different collections, such as we have lists, queues, maps, and sets. Now, even though maps is not part of the collections framework, which consists of list, queue, and set, we will be discussing the map in this series as well. Now, since this is part 4, we're going to talk about lists, and we're going to hop into the array list and the linked list. Now, why do you mention array list and linked list? It's because list here is an interface. Now, it's because the list here is an interface, and once you actually write some code, you're going to understand why. And let's get straight to it. Alright, so what is a list? So basically a list is it's a sequential resizable data structure. Now what makes an array different than a list? So an array usually has a fixed size. And a similar thing about an array that it is for a list is that they both have indices starting at 0, fortunately. So, in order to create a list, you're going to go ahead and do list, and then let's say you got L1. You want L1 right here, equals new. Now, you may be tempted to do list right here, but it's only really useful to do list if you can actually provide method bodies for all of those. And as you see, you get a ton of methods here, which obviously you don't want here because we need an interface here. And we haven't talked about anonymous inner classes yet. And this is basically implementing a linked list here as well. So instead, what we can do is choose a class that extends. Let's choose a class that implements the list interface. So one example is an array list. So array list is basically a list used as an array. Now, I did mention that arrays are fixed in size, but you can actually add to an array by making a new array and then copying all the old elements and then putting the new element in the array. And that's essentially done by making sure the new array has a size of 1 greater than the original array. And then you gotta set the original array to of course the new array that you just made. And likewise for removing, you still have to create a new array. So lists provide easy accessibility to remove here as well. So L1.remove. Now we don't have anything to remove because once we create the list, we have no objects in them. So we have to add some objects here. Now there are two methods. You can add an object to the end of the list, or you can add an object at a specific index. So we can add anything right here, 78. We can add a char a right here. So we don't have any generics because we want to show you how it's possible that this can be without generics as well. So L1.add, let's add this character, and let's say you want a double here as well, and you need not a string. Let's just go ahead and do a boolean true. Here we go. And in order to display the list, you want to go ahead and do system.out.println the list right here. Now the main reason this works, unlike arrays, is that the ArrayList class actually has a toString, which prints all the elements in the form of an array, which basically is the brackets right here, brackets right here as well. So that's the toString representation of this. Now, what if we actually added a generic with a specific data type? Now, if we want to remove the warnings, we can actually do list object. But keep in mind, object is the default data type here. So object is all of these things. So this is integer, this is character, this is double, and this is Boolean. And of course, we want to keep in mind that in the add method, this method is a Boolean. So if the method was actually added successfully, then true will be returned here. So we're actually going to go ahead and return this just one time, and if we want to run it, then we should be able to get, let's just say, true right here. So we got true. Now the add operation is still being performed here. So that is something else right here. So keep in mind, this is not the only thing that list can do. So list can also remove. And keep in mind, you have two different methods. You can remove an index, and you can also remove a specific object right here. Now if you want to remove an object that is of type integer, you want to keep in mind that if you do provide the primitive type, IntelliJ at least will identify this as an index, and we definitely do not have 78 elements. So an easy way to fix this is to add an integer cast right here. Now, this is a primitive type int, but integer is a wrapper class right here. Integer here is a wrapper class, so it is an object right here. So it's definitely a reference. Anything here is definitely a reference type. So that's why. Now, I did mention that there is another add method that will add a specific index here. So we get 2, even if the index is 1 above the size, is equivalent to the size, current size, it's fine. But we can, oh yeah, I forgot semicolon. Yeah, so after running this, we should be able to get true, and then we also get 89 as well. Now, of course, in the data structures and algorithms, which I'm going to be posting, we're going to go ahead and provide the deep implementations for the linked list as well. So array list is one of them, and the linked list is another one of them. I did provide some descriptions, but yeah, let's go ahead and see some other methods as well. So like an array, you can actually set an index to an element. And of course, this method will actually return the object at the index before being set. So currently in index 1, you will have like character A. So that's how you get character A. So that's how you print out A right here. Or particularly, oh yeah, it's like a one that's set right here. Oh yeah, because we removed 78. We also removed 78, so we actually print out 98.1. We actually print 98.1 as well, so that is definitely something here. Okay, so anyway, let's just go ahead and see what other methods there are. There are add, set, then there's remove, there's clear. Then of course there's clear, which basically removes all the elements in the list right here. Then there's contains, index of, and then you can do a list iterator. Then you got size right here. Now of course, now that we've gone over this, we're gonna focus on retrieving the elements now. So L1.get an index right here. So at index 1, after we get index 1, we should be able to get, let's just say, 89. There we go. There we go. So now we know how to use set, get, add, and remove. So keep in mind that this is an object remove right here, and this is a boolean to show that the object is removed successfully here. So now we're going to go ahead and provide ways towards iterating a list right here. So there's definitely more than 2 ways. You can use a while loop right here. So keep in mind, when using a while loop, you do have to create an outer variable for the index. and then do while index is less than, you have L1 dot size. Size is basically the number of elements in the list right here. And we do get some errors, so while statement has empty body, any condition is not updated inside loop. So we just do index plus plus, and now we're just going to system out print line L1 dot gets index, because we want to get every element here. So I'm just going to go ahead and remove the system out print line here. I'm just going to remove the system out print line right here. So, and this is just going to be the old list right here. So right now the while loop body should be printing here. Hold on. Yeah. I don't know if I actually run. Oh yeah, there it goes. 89, 98.1, and true. There we go. After you removed it. After we removed it, of course. So I'll just comment that now. And we should be able to get we got 78 and A as well. So this is not the only way. So number 1, then we got number 2. We can use a for loop here. We can also use a for loop, which is probably the preferred way. So int I equals 0, I is going to be less than. We do L1 dot size, number of elements here, I plus plus. So this is definitely the most straightforward way. So these are definitely the most straightforward ways right here. So L1 dot gets I, and keep in mind inside this body with the 3 arguments, you have the assignment, and then you have the comparator, and then you have the incrementer basically. And this is the second way you can do this. Either way, we should be able to get the same results because we did system.out.println. There we go. And then number 3, we can also use an enhanced for loop. Now the reason we can do this is because this is a list. Even though IntelliJ tells us that enhanced for can be placed here, so we can use enhanced for loop here using a colon, and then you do the list here, and particularly the data type here. So you want object here, you want O, and then you want to system out println O. So of course you gotta keep in mind with the enhanced for loop that you can only print forwards, like you can't print in reverse. So this is number 3. I actually forgot to comment the above here, so this will obviously be printing twice. So I believe the fourth method is actually very complicated here and requires the use of a list iterator. So if we know how to use a list iterator, so we do list iterator. Now we want to keep in mind that list iterator is an interface, and we can have a generic here. So, and we're going to call it iterator here equals. Now of course we don't want to set it equal to new list iterator because we don't want to provide our own custom implementation. We want to use Java's built-in iterator. So we do the list dot list iterator, and this is of type list iterator as well. So how do you actually use the list iterator? So we're actually going to use while the iterator dot has next, and then we want to system out println iterator dot next. Now I know this isn't the best way to think about this, but the has next basically means that the cursor of the iterator is, if this isn't the last place in the cursor, if there are any elements past the current position. Otherwise, this will print out the iterator.next here, and the cursor will advance here. So after we run this, we should be able to get, here we go. So this is basically the video on lists. If you guys enjoyed, make sure to leave a like and subscribe, and I'll see you in the video where we talk about queues.